In this video, we are going to solve May-June 2023 Pure Math 4 paper. This paper consists of 8 questions. Let's start from question number 1. Question number 1 is from binomial expansion. The binomial expansion is this: 1 plus x to the power n is equal to 1 plus nx plus n times n minus 1 over 2 factorial x square n times n minus 1 times n minus 2 over 3 factorial x cube plus etc. The n is the power. It can be any number, positive, negative, fraction, anything. And the second term we take it as x. The first term has to be 1. You cannot have any other number there. You see, you have 1 over 4 here. You need to change it to 1 actually. So this binomial expansion is given in the data booklet. You can copy the binomial expansion from there if you don't want to memorize. So to apply the binomial expansion, first we need to get rid of this first term. So I'm going to take the 1 over 4 outside as a common factor. So when I take 1 over 4 outside, it will come together with the power. So the first term becomes 1. The second term becomes, you need to multiply by 4. 4 over 2 is 2x. If you don't understand the step, try to multiply both terms by 1 over 4. 1 over 4 times 1, you will get the first term. 1 over 4 times minus 2x, you will get the second term. Okay, is equal to 1 over 4 power minus 3 over 2 is same as 4 power positive 3 over 2. 4 over 1 power positive 3 over 2. So 4 to the power 3 over 2 is 8. So this is basically 8 outside. And then we are going to apply the binomial expansion and find the first 4 terms. The binomial expansion is this: 1 plus nx, x is the second term, plus n times n minus 1 over 2 factorial times x square, n times n minus 1 times n minus 2 by 3 factorial x cubed. That's it. We got the 4 terms already. Now we need to carefully simplify this. So is equal to 8 times 1. Let's simplify this term, and negative times positive, you will get negative. The 2 can be cancelled, you will get 3x, 1 minus 3x. And then let's move on to the next term. I'm going to simplify this first. Okay, minus 3 over 2 times minus 3 over 2 minus 1. 15 over 4 divided by 2 factorial. 2 factorial is just 2. 15 over 8. So we get positive 15 over 8 times 2x whole square is 2 square x square. That's all. And then the next term, I'm going to simplify just this first. So we have this answer before. Okay, probably we got 15 over 4, I think 15 over 4 by simplifying just the first 2 factors, minus 3 over 2 times minus 3 over 2 minus 1. Now I'm gonna put I'm gonna multiply this with minus 3 over 2. If you don't understand, just write the whole thing here. So what I'm doing, minus 2 divided by 6. 3 factorial is 6, so divided by 6 is negative 35 over 16. Okay, negative 35 over 16. 2 cube x cube is 8x cube. That's all. Now you just need to simplify it further and then multiply each and every term by 8. So you will get 8 minus 8 3s are 24x. When you multiply 8 with this term, 8 will be cancelled. 15 times 4. 15 times 4 is 30, 60. 60x square. I just realized a little mistake we made here. This is the common mistake you are also going to make in the exam. When we find the expansion, listen to me carefully. The second term is minus 2x, not just 2x. You cannot take it as just 2x. Your answer will be wrong. Your answer in the sense, the sign in the answer will be wrong. So here it has to be minus 2x, minus 2x whole square, minus 2x whole cube. So this will be positive 3x. This also will be positive. So we'll get positive 24x, 60x square. When you multiply these two, you will get 35 times 4, 140x cubed. That's the answer for part A. Let's move on to part B. Given that this is equal to this, write the value of n. It's very simple actually. It's take this as a. You have a power n times a power negative 3 over 2 is a power half. Here you have a power n minus by applying laws of indices. The base are same, so you equate the power is equal to 1 over 2. So n is 1 over 2 plus 3 over 2 is just 2. That's it. Just a 1 mark question. Let's move on to part C now. Hence or otherwise, find the first 3 terms of the binomial expansion in ascending order. This one. You can in fact treat this as a separate equation, separate binomial expansion, and find the first 3 terms. That's one way of solving it. Or you can use the result from here actually. So you see what I'm going to do. If it's power half, I can write it in this form actually. Power 3 by 2 and power 2. So that's what I'm going to do. Okay. I think most of the students, they don't want to do that. They are going to treat this as a separate binomial and apply the binomial expansion. That's completely alright. But you need to know this method also. Because what if the question says you need to use the answer from part B to solve it. So you need to write this as 1 over 4 minus half x to the power half was equal to, from the previous part we can write this as 1 over 4 minus this power 2, 1 over 4 minus this power negative 3 over. The first one is a minus b whole square. So I'm going to expand it. A square minus 2ab, b is half x, plus b square times, take the binomial expansion from part A, which is 8 plus 24x plus 60x square. You don't need the fourth term, they want only the first 3 terms actually. And then just open the bracket, you will get the answer. You see how I'm going to do that. First, the first bracket, when you expand it, simplify it, 1 over 16 minus 1 over 4x plus 1 over 4x square times 8 plus 24x plus 60x square. You need to expand the bracket, simplify the like terms now. You will get the constant term, first term, by multiplying these two. You will get just 1 over 2. You will get the second term by multiplying this and this and this and this. So that's going to be, if you take x as a common factor, 1 over 16 times 24. 1 over 16 times 24 is 3 over 2. And then minus 1 over 4 times 8 is minus 2 times x. And then you get the third term by multiplying this and this. Sorry, first this and this. This and this, which is going to be 1 over 16 times 16. 1 over 16 times 16 is 15 over 4 plus 15 over 4. I'm going to take x square as a common factor. And then when you multiply this term by this term, you will get x square. 1 over 4 into 24, 6 4s are 24, so you will get minus 6. And then when you multiply, what is the next term? This and this, you will get x square. 1 over 4 times 8 is just 2. So you will get plus 2x square. Simplify it now. So you will get 1 over 2 is the first term. 3 minus 4 minus 1 over 2x is the second term. The third term is going to be 15 over 4 minus 4 is negative 1 over 4 x square. That's all. That's it. Question number 2. We have a diagram given and there is a point P marked there. The figure 1 shows a sketch of the part of the curve with the equation 2 power x minus 4xy plus y square is equal to 30, where y is greater than or equal to 0. Apparently from the figure, the graph takes only positive values. There is no graph below the x-axis. Okay. Point P lies on C with x coordinate 2. Find the y coordinates. Very simple. Sub in this in the place of x here. So it's going to be x is equal to 2 implies 2 power 2 minus 4 times 2 times y plus y square is equal to 13, or put the 13 also here, minus 13 is 0. So you get a quadratic y square minus 8y, 4 minus 13 is minus 9 is 0. You can write it as y minus 9 times y plus 1 is equal to 0. Y is equal to negative 1 or 9. Apparently the y takes only positive values, therefore y is equal to 9. That's all, part A. Easy 2 mark question. Let's move on to part B now. Find dy by dx in terms of x and y. Let's write the function 2 power x minus 4xy plus y square is equal to 13, right? We need to apply implicit differentiation here. So derivative of 2 power x is 2 power x ln 2 minus. Here we apply the product rule. Minus is a common minus. I'm going to keep 4x as it is. Derivative of y is 1, but you need to put dy by dx with it. Plus. Keep the second function y as it is. Derivative of 4x is 4. That's a product rule. Plus. Differentiate y square now. 2y times dy by dx is equal to 13 becomes 0. Now we just need to make dy by dx as a subject. So 2 power x ln 2 minus 4x dy by dx minus 4y plus 2y dy over dx is equal to 0. Simplify the like terms. I'm going to bring this term and this term to the other side and take dy by dx from the other two terms. I will get 2y minus 4x dy over dx is equal to 4y minus 2 power x ln 2. And then divide by 2y minus 4x, you got dy by dx already. Dy over dx is equal to 4y minus 2 power x ln 2 divided by 2y minus 4x. It's a 5 mark question. You need to know the implicit differentiation. Implicit differentiation is just a normal differentiation. You need to treat y also as a variable and differentiate it. But whenever you differentiate y, you have to put dy by dx with it. That's implicit differentiation. Now let's move on to part C now. Part C says the tangent to C at P crosses x-axis at Q. Find the x coordinate of Q. Give your answer in this form. First of all, you need to know the equation of the tangent. So in the equation of the tangent, to find the x-intercept crosses x-axis at Q. To find the x-intercept, we need to put y is equal to 0 in the equation of the tangent. We know the x and y coordinate of P. That's the first thing we did here, 2, 9. So we know point P is 2, 9. And we know dy by dx from the previous part. Dy by dx is 4y minus 2 power x ln 2 divided by 2y minus 4x, I guess. Yes. So we can find the slope of the tangent is equal to find the slope of the tangent, you replace x and y by these coordinates. 4 times 9 minus 2 power 2 ln 2 divided by 2 times 9 minus 4 times 2. So that's going to be 36 minus 4 ln 2 divided by 18 minus 8 is just 10. Or take 2 as a common factor and cancel. You'll get 18 minus 2 ln 2 divided by 5. That's a slope. So the equation of the tangent is y minus y1 is equal to slope is this times x minus x1. We don't need the equation of the tangent. We are not finding the equation of the tangent. We are just finding the x-intercept of the equation. So from here you can straight away replace y by 0 and make x as a subject, because they want you to find the x coordinate of the point where the line crosses the x-axis. Basically they want you to find the x-intercept of the line. So what I'm going to do now, I'm going to replace y by 0 in this equation. So I will get negative 9 is equal to 18 minus 2 ln 2 divided by 15 times x minus 2. Make x as a subject and write it in this form. So it's going to be, bring the 15 here, so 9 times 15 is 135 minus 135 is equal to, or bring the 18 also this side, 18 divided by 2 ln 2 is equal to x minus 2. And bring the minus 2 this side, so x is going to be minus 135 divided by 18 minus 2 ln 2. First of all, how we got 15 in the denominator? It was 5, I think. The denominator was 10, it was 5 actually, not 15. So 9 5s are 45. So it was 45 actually, plus 2. So multiply and divide this term by 18 minus 2 ln 2 to make it as a common denominator. So you will get 18 minus 2 ln 2. On top you will have negative 45 plus 36 minus 4 ln 2. Simplify. Negative 45 plus 36 is negative 9. Negative 9 minus 4 ln 2 divided by 18 minus 2 ln 2. That's the x coordinate in this form. If you want, you can multiply and divide by, multiply both numerator and denominator by negative 1 and write it in this format. X is equal to, you will get 9 plus 4 ln 2 divided by minus 18 plus 2 ln 2. Both are correct anyway. This is also correct, this is also correct. That's all. Question number 3 now. Express f of x in partial fractions. Okay, first thing we need to check whether it's proper or improper. The degree of numerator is 1. If you expand, you will get degree of denominator as 2. 1 over 2 is a proper fraction. For proper fraction, we can just put a constant for every factors actually. You can write it as a over 2x minus 1 plus b over 4x minus 3. and take the denominator and multiply, you will get 8x minus 5 is equal to 8x minus 5 is equal to 8 times 4x minus 3 plus b times 2x minus 1. I'm gonna replace x by half. 8 times half is 4. 4 minus 5 is negative 1 is equal to, this becomes 0 when you replace x by half, because 2 times half is 1, 1 minus 1 is 0. 8 times 4 times half is 2, 2 minus 1 is negative 1, so a is equal to positive 1. And then I'm going to replace x by 0 on both sides of the equation. So when I replace x by 0, this becomes 0, this becomes 0, this becomes 0. Replace a by 1 also. You will get negative 5 is equal to negative 3 minus b. So minus b is minus 2, b is equal to 2. We got the value of a and b. So if you don't want to lose 1 mark, you better write finally, sub in the values of a and b here and write it in this form. This is equal to this. If you don't write this step, you will lose 1 mark. So you need to write this. That's all. It's a 3-mark question. Let's move on to part B. Now they want us to integrate it. Integrating the function is given here, is same as integrating this one. Is same as integrating 1 over 2x minus 1 plus 2 over 4x minus 3 dx. So in integral, when you see a linear function without any extra variables, there are only 2 rules. First one is this: ax plus b dx is equal to ln modulus ax plus b divided by a plus c. If the ax plus b has any other power, you write it as ax plus b power n plus 1 by n plus 1 times 1 over the coefficient of x plus c. Only 2 rules for a linear function, provided you cannot have any of the extra variables. So I'm going to apply this rule. So the first one becomes ln modulus 2x minus 1 divided by 2 plus 2 ln modulus 4x minus 3 divided by 4 plus c. So you cancel the 2 and 4. This becomes 2. So write one more step: ln 2x minus 1 divided by 2 ln 4x minus 3 modulus divided by 2 plus c. That's the answer. Again, another 3-mark question. Let's move on to part C of the question. Now the same thing, definite integral now is equal to this. So they want you to find the value of k. So I'm going to take the answer from the previous part. In the previous part we got 1 over 2. If I take 1 over 2 as a common factor here and leave this plus c because it's a definite integral now. So it's going to be 1 over 2 ln 2x minus 1 plus ln 4x minus 3 is equal to half ln 20. You can cancel this half both sides, and we need to sub in the limits actually, 3k, k to 3k. So when I replace x by upper limit 3k, I will get ln, I can put it as a single logarithm actually, ln a times b. So 2 times 3k is 6k minus 1 times 4 times 3k, 12k minus 3 modulus minus lower limit, replace x by k, ln 2k minus 1 times 4k minus 3 modulus is equal to ln 20. Now combine it to a single logarithm here, ln 6k minus 1 times 12k minus 3 divided by 2k minus 1 times 4k minus 3 modulus is equal to ln 20. Now you say the k is basically the values of x actually, right? The limits are the values of x. And in the function it's clearly mentioned x is greater than 1. If x is greater than 1, k is also greater than 1, right? Because the limits are the values of x. So if k is greater than 1, this is also positive, 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 positive. All these values are positive numbers, so we don't need a modulus sign here. We can just remove the modulus sign. And you can remove L on both sides. So basically you will get 6k minus 1 times 12k minus 3 divided by 2k minus 1 times 4k minus 3 is equal to 20. Open the brackets, you get a quadratic, bring the quadratic here. Here also open the brackets. So you will get 6 times 12 is 60, 72k square minus 18k minus 12k plus 3 is equal to 20 times, bring this here, you will get 8k square minus 6k minus 4k plus 3. Open the bracket and put everything one side, you will get a quadratic. So you will get 20 times 8, 20 times 8 minus, we have 72, which is 88k square, and the 20 times this minus 20 times minus 10k is 200k, and you have here 30k. So you will get minus 200 plus 30 is minus 170k. And then we have 60 here, the 3 comes here, 60 minus 3 is 57 is equal to 0. So I'm going to solve this quadratic now. Go to equation quadratic, 88 negative 170 plus 57 is 3 over 2, 19 over 40, 44. K is 19 over 44, 3 over 2. This value is smaller than 1, so ignore it. This value of k. K is equal to 3 over 2, because k should be bigger than 1, right? K is the value of x actually. It should be greater than 1. That's all.